Let's understand kinetic theory in this video.
Have you ever wondered why a balloon shrinks in the cold and expands in the heat? Or why gases always fill their container evenly no matter the shape?
These everyday facts come from the ideas in kinetic theory, and we will see them step by step. First, the basic picture. Every gas is made of many tiny particles called molecules. All molecules of one gas behave the same, but different gases have different molecules. We treat these molecules as tiny, hard, and elastic point masses, so their own size is much smaller than the distance between them. They move very fast, with speeds ranging from nearly zero to very large values. Between two collisions, a molecule travels a distance called the free path, and the average of these distances is the mean free path. The number of collisions in each unit of volume stays constant on average. We assume there are no lasting forces of attraction or repulsion between molecules because their masses are tiny and speeds are high. Now the gas laws, which experiments showed, are true for many gases. Boyle's law says that at constant temperature, volume is inversely proportional to pressure. In words, PV equals constant, and so P1V1 equals P2V2 for the same gas when temperature does not change. Charles' law says that at constant pressure, volume is proportional to absolute temperature. So V divided by T equals constant, and V at temperature T equals V at 0 degrees times the quantity 1 plus T divided by 273.15. Gay-Lussac's law says that at constant volume, pressure is proportional to absolute temperature. So P divided by T equals constant. Thus, P at temperature T equals P at 0 degrees times the quantity 1 plus T divided by 273.15. Avogadro's idea is that equal volumes of gases at the same temperature and pressure contain equal numbers of molecules. Avogadro's number is 6.023 times 10 to the power 23 molecules per gram mole. And 1 mole of any gas at standard conditions occupies 22.4 liters. Perfect or ideal gases follow all these laws and satisfy the equation PV equals nRT, where R is the universal gas constant and N is the number of moles. R equals 8.31 joules per mole per Kelvin. Real gases differ because their molecules attract each other a little and they take up some finite volume. Van der Waals corrected this by writing the equation quantity P plus A divided by V squared times the quantity V minus B equals RT, where A and B are constants that fix these effects. From kinetic theory, we can also connect pressure to molecular motion. Pressure equals 1/3 times the quantity Mn divided by V times C squared, which is the same as 1/3 times rho times C squared. For 1 mole, this becomes P equals 1/3 times the quantity M divided by V times C squared. Also, pressure equals 2/3 times E, where E is the kinetic energy per unit volume of the gas. The average kinetic energy per molecule is E equals 3 divided by 2 times K times T, where K is Boltzmann's constant. Per mole, the average kinetic energy is 3 divided by 2 times R times T. So kinetic energy is directly proportional to temperature. The root mean square speed, that is the RMS speed, equals the square root of the quantity 3RT divided by M, or equivalently, the square root of the quantity 3KT divided by M. The RMS speed grows as the square root of temperature, and for different gases, it varies inversely as the square root of molecular weight. Boltzmann's constant is K equals R divided by N, and in this text, its value is given as 1.38 times 10 to the power minus 28 joules per Kelvin. There are also formulas for average speed and the most probable speed. The most probable speed equals the square root of the quantity 2kT divided by m, and the average speed equals the square root of the quantity 8kT divided by
pi times m. So what do we learn from this?
We learn that gas pressure and energy come from molecules moving and colliding, and that temperature measures the average kinetic energy of those molecules.
Let us quickly remember. Assumptions describe fast, tiny, elastic molecules. Gas laws link pressure, volume, and temperature. And kinetic formulas link speed and energy to temperature. So today we learn the main assumptions: Boyle's law, Charles' law, Gay-Lussac's law, Avogadro's idea, the ideal gas equation, van der Waals correction, and how kinetic theory gives pressure, energy, and speeds. Keep exploring these ideas with simple problems. Draw motion and collisions on a board and check the formulas with numbers you know. Stay curious, take small steps, and practice a few examples to make the ideas stick. If you want more clear notes and practice, explore more on EduRev at your own pace and keep learning without pressure.